In this video, I'm going to be going over Piezo Kinetics, which is a supplier of piezo ceramics. I'll explain some of my experience with this company, why I think it is particularly attractive as a supplier of piezo ceramics, and also we're going to go over their some of their materials as well. So Piezo Kinetics, they are based in, as it's shown here, Bellefonte, Pennsylvania, which is right next to Penn State University, which has been known for a lot of innovation. It's, Penn State and State College in that area is kind of known as the, I guess, piezo ceramic or piezoelectric capital of maybe United States because of the amount of businesses, research, and technology coming out of that region. It's a hotspot, definitely. So Piezo Kinetics is kind of right there along with that whole industry and business and industry research vibe. So they are one of the unique suppliers. I believe from my understanding that they produce all of their ceramics in the United States at their facility. That's unlike a lot of others who maybe who completely outsourced it overseas, or they're European suppliers, or they are kind of a mix and match. A part of the supply, part of the manufacturing happens of the ceramics in the United States, and part of it, some certain materials are manufactured overseas, either in Europe or in Asia. So I believe this is a unique company in the sense that all their ceramics are made in the United States. And why that's important is it's because it's easy to access the right personnel and work closely with their team, for any better understanding of their ceramics, their devices, what they produce for you, what you're buying. So it's a shorter chain of communication, and I think that's very important for projects. So they've been around for a long time. I actually toured their facility when I was a PhD researcher. I toured their facility when I was actually doing my PhD at Penn State. So that's kind of a unique thing there. So I have not had an extensive amount of experience using their ceramics in applications, but I have seen for sure folks in medical. There's a specific medical company that I had worked for a few years ago that had used their ceramics, and they've always been kind of present at different conferences as well as other industry events. So they're very well represented. They are in there with and they understand the companies and the needs of their clients and their customers. So I want to go here. So they're like many other ceramic suppliers that they also provide kind of value-added components. They provide different shapes according to their customer needs. Here you see, I think somebody's soldering. They provide that extra kind of additional work done on your device, and they'd probably obviously also do that to an expert degree because that's what they work in. What mostly almost all people working in ultrasonics and piezoelectric materials are interested in PZT, lead zirconate titanate. They also offer another material, and we'll take a look there. They also offer lead metaniobates, which I have not used before, so I'm not really going to speak on that. I think it's as you're mentioning, it's a little bit more of a high frequency pulse echo measurements with short critical resolution. That's not really what I've worked on in the past. I work on power ultrasonics. So let's go over some of their materials. And this is perhaps some information you'd also be able to receive from them. But yeah, I just like to kind of give my own personal experience with this company, which has been positive, and also make sure you understand. And I believe this is true, that they provide all of their ceramics from the U.S., and that would be important. One of a distinguishing factor, which would be important for me in purchasing ceramics from a company. But I also believe price is a concern when you're talking about Asian suppliers versus U.S. suppliers versus European suppliers. They all have their different price ranges. But in addition to price, which is obviously a very important factor, especially when you're going mass production, and depending on how many samples you need, the other thing that's really important is your business dealings. What kind of business dealings you feel. I'm not going to give any input here, but based on, I recommend that whichever one of the big factors and whether you want to deal with a company is how easy you feel they are to deal with. So I'm not speaking about Piezo Kinetics, if they're easy, hard, whatever. That's for you to decide. I'm not going to give any kind of specific opinion on that. And I'm doing some videos on other ceramic suppliers too, and just trying to give what I feel is the really positive things about them, so that you can kind of take that into consideration. So they have several of the basic types of PZT, lead zirconate titanates. This is the material you're going to be using. It's a ceramic. It's stiff. It's hard, and it's obviously in order to apply it, you need to attach it to different. In most cases, you need to attach it to different structures, which then resonate, which then amplify vibration, which then dictate the resonant frequency, and so on and so forth. So they have their basic Navy types, which, Navy type 1 is kind of the first piezoelectric material used. I believe that Navy type 1 is hard in the sense that it has a higher mechanical quality factor, around 500 or so. And the reason why it's hard doped is because iron pellets, I believe iron pellets were first used to manufacture PZT materials in terms of grinding the powder, as you kind of see in this corner here, grinding the powder. And therefore kind of iron material got in the powder and kind of made it into a harder, the doping that iron causes, the effect is that it makes it a harder material, which means it has a higher quality factor, and generally slightly lower D33 and coupling factors. But then after that, sensor type materials, as you see here, each company has its own name for the material, but they always designate it kind of back toward an original class. And one might wonder, like, okay, why are there 3 classes for the specific Navy Type 3? For Navy Type 3 is specifically developed to have the highest quality factor. Unlike Navy Type 1, which is kind of like a mid-grade in the quality factor, you could say, this is very high for applications requiring a high quality factor, such as challenging high power ultrasonic transducers. Then Navy Type 5, so Navy Type 2 was the sensors. Navy Type 5 has a different dielectric properties. So this is also kind of true for these materials. They may have different Curie temperatures depending on your application. They may have different dielectric constants, specifically to, many high power applications aren't as picky, except that if you're going to the temperature region, there may be some distinguishing factors between these 3 materials, or specifically the one maybe they have on staff. I'm not speaking out of experience. I think specifically perhaps the one they have or are selling, if they actually change the composition for a certain reason, they may have labeled it something different instead of just passing it the same material. Ask the company for more details for sure. I'm not affiliated with this company. So this specifically is a sensor material. Obviously, this has a high D33 coefficient, but it also has a high dielectric constant. And here is Navy Type 6, which has an extremely high dielectric constant, as it says here, and it's meant to give a higher G33 coefficient. So we can also take a look at the company, kind of the data sheet here, to see how they present it. And you see with the Navy Type 1, you see the mechanical quality factor of 500. The Navy Type 3, it's 900 to 1,000. You can see the densities for piezo materials are generally the same. This is the lead metal niobate section. Not really much experience with that personally. You see the different Curie temperatures. You're going to have to operate a good number of, several, like 100 degrees lower than that approximately, probably, for stability. As you increase temperature in your application, these properties all go wild. Like the dielectric constant shoots up. the D coefficient shoots up and the losses also shoot up. So the quality factor decreases significantly. So these material properties only hold for room temperature style measurements. Let's see, anything else? So yeah, as you can see, there are a bunch of different materials in each class. They may differ on the spectrum shown here between the material property values, because this is quite a range, 350 to 550. It's quite a range there. But you can also specify for your, for your specific material what tolerances you would like. You kind of first needed to get a few samples in order to try out your idea, your design, before understanding whether and what kind of properties you then need. So going back to their website, so I mentioned I do recommend them for purchasing piezo ceramics. They have the standard material classes. They're based out of out of the U.S. and I think they primarily manufacture there, which is a huge positive in my opinion, in order to have a close working relationship with the company. And in case there are other questions or comments or concerns, then you'll be able to kind of get to the right person a little bit sooner. I believe this is a smaller company than some of the European conglomerates, such as Ceramtech and PI Ceramic. So that is something to note versus the Asian suppliers are kind of in their own class, and you'd most likely be looking toward them for price considerations, not for thousands of ceramics a year. That wouldn't probably be something I would do. But yeah, so I kind of that's that's kind of the last bit I have to mention. And my name is Hussein Shakani. I'm the founder and lead consultant of my company, Ultrasonic Advisors, where I help companies to use ceramics from companies like Piezo Kinetics and Intense Consulting. I do simulations, transducer development efforts. I don't sell ceramics. I'm just making this video as as kind of vouching for different companies that exist and mentioning my positive experience with each of them. All right, I hope you found this video useful, and I look forward to seeing you around, or email me if you have other questions, or obviously get in contact with this company if you have questions about their product. All right, thank you.